Hello, everyone. Thanks so much for joining us for this webinar. My name is Tracy Onim, Elixir Webinar Organizer. Once the session has started, if at any point you cannot hear the speaker or see the screen, the shared screen, please let us know through the chat. Beware that as we progress, we may experience technical difficulties, and if this happens, we'll try our best to recover as quickly as we can. So I'm pleased to introduce today's speaker, Sigu Magwa. For those who don't know him, Sigu is a software developer and founder of a software company famously known as Podii. He thrives in mentorship and community empowerment through positively impacting the tech ecosystem. And also, he will be a keynote speaker at ElixirConf in April. Before I hand it over to Sigu, I have a few things to point out. First, today's webinar recording will be available on our YouTube channel. Next, we'd love to hear from you during today's presentation. If you have any question for our speaker, please feel free to ask at the end of the session. Also, leave a question on the chat if there's any. And last, we'd like to encourage you to share today's webinar with your social networks. So without any further ado, I'd like to welcome our speaker, Sigu Magwa. Sigu, are you ready?
Thank you very much, Tracy. Can you hear me?
Yes, we can hear you.
All right, thank you very much. So let me just share my screen and get started. Share that, start sharing. I hope you can see my screen. Okay, with the assumption that you can see my screen, just first warning, there might be some movements around, so if you hear a baby crying or someone moving around, don't mind about it. Secondly, the quick introduction onto this session today. I have tried to avoid writing code just so that we don't have too much details during this particular session. I'll not really go into the details of what's happening and whatever I talk about, just so that we can skim through everything and you can have an idea of what we're talking about. And the third thing is I might be mentioning some tools here. They are not a sponsor of the show in any way. They don't sponsor us, so just keep in mind about that. Yeah, we just happen to use them at one point or another, or I just happen to know about them. There's also so much that I'm going to say that are not written here, so you need to do more of listening than reading onto these particular presentations. All right, moving over to just a minute. Yep. Okay, so the agenda of the day is to try and convince you, if you're not in Elixir, so that you can join the Elixir community or start using Elixir. Second agenda is to show you how to write good code in Elixir as a team. The other one is structuring your code or files or system, or really how to structure the team that you're working with Elixir. Then also how to get into production with Elixir for the day. So just a few things that gets me excited about Elixir, or that I need to talk about in Elixir. If you've never used it before, they're very important and you need to have an idea of what they are, or yeah, you really need to have an idea of what they are. I'll start with talking about data, which is the main point of focus in Elixir because it's a functional and immutable language. So data is, in Elixir, you transform the data, you don't mutate the data. So basically what it means is, let me get an example here. If, what's that? Let me hope that we all can understand what this is. This, I didn't have to open that. Yes. We all know what this is. It's maze, okay? So think about it. Let's assume we are 3 of us and we have a cob. It's called a cob of maize, I think. Yeah, so we have this particular maze for the three of us. Now, what immutability, let's start with immutability. What immutability does is if the first person takes up the maze and they mutate it, mutating in this case is biting it off, so they eat off a few seeds. Then by the time it gets to the next person, it is not the same maze that we started with. So this basically means that if I have this maze and I eat it, then I pass it to the next person and to the third person, it might not get to the fourth. So the fourth person is never sure about what they're going to get because it mutates what we have. Immutability is having a copy of the maze. So if everyone asks about the maze, they'll get an exact copy of this particular maze. So if we are the three of us, then I take the maze and bite it off. If the next person asks for the maze, they don't get the maze that was bit off. They get this exact maze. So we all have the advantage of eating our maze at our own pace. So if you wanted to eat your maze for 3-4 hours, it's perfect. So no one is going to clear up your maze. So basically, that's the difference between mutability and immutability. Onto the code side, if you have a list or commonly known as an array, which has, let's say, 4 items, if a particular code needs to do something to that particular list, then for immutable data, you are 100% sure that you're going to get the list that was initially there, unless it's been reassigned. But in most cases, if you expected a particular list, that is the list you're going to get. So it's kind of you're getting a copy of it, just like the other person was getting a copy of the maze. Okay, I don't know if that's clear or not. So that's immutability. Other than mutability, let me just expand on this. So in Elixir or in functional programming, we usually think about the data that we need to transform. We stop thinking about how the transformation happens, but we really think about what data we have and the final product that we need. So going back to the maze analogy again, if the data that we have in is maize with seeds, then what we need is only the cob. So it needs to have been eaten off. So we care about the maze. In other languages or in if you think about other concepts of programming, you really care about how you're going to eat this maze. So you might forget about the end result and concentrate so much on how this is going to happen. Another amazing thing about Elixir is pattern matching, which allows you to have more than one function head. I know I'm talking about abstract things. I'm sorry, I didn't want to write any code here, just so that to introduce the complexities. So pattern matching basically means that you can decide how things happen. So it's technically a form of polymorphism. It's basically a form of polymorphism if you've ever done some computer science before. So it allows you to do with the same function call, you can do different things. So for example, a common thing is let's say you want to print out or you want to manipulate particular data. You want to show the list. You want, okay, sorry about that. So for example, let's say you're dealing with either a string or a list. You can have a function with the same name that can choose whether it's going to work with a string or a list. It's normally called a guard clause. So you can have a guard clause that normally does that for you for the pattern matching. Let's talk about concurrency. Generally, concurrency is I'll talk about it as a concept, not from the programming end. Concurrency in this case is, let's see, we in East Africa, we're having a problem right now. So I can just share my screen and get it from this end. I think I'm done with this maze. Let's just do away with that. Let's move on to the next thing that we have a problem with. It's the locust. Okay. So I want to use the locust to explain what concurrency can be. If you have these two locusts and they are in your farm or in your compound, then I don't know how long it might take, but I guess it's going to take a lot of months for them to do this kind of damage. This kind of damage to your trees. Okay, so if you have only 2 locusts, they can eat not so many leaves at the same time. Currently, we're having a problem of locusts where they come in thousands and thousands, and if they land on such a tree, they won't take 5 minutes for them to do away with the leaves. Concurrency is technically the same thing, where you let independent things work on one particular thing to finish it up. So you work on they work on a particular thing to finish it up. So the independent things in our case is the locust. They work on the leaves just to finish up that particular leaf. So that's what concurrency allows us to do. So Elixir is very good in concurrency. I won't go into the details of explaining how that happens today, but it's one of the amazing things about Elixir. ETS, it's in-memory storage where you can use it for things like caching. You don't need a third-party library for you to do caching. You can use ETS. Gen servers, as I said before, Elixir being immutable, Elixir data being immutable, there's no straight way of keeping state. So we have to invent or have ways of keeping track of state, because once you use data, once you have a certain set of data, that's particular data. So if you try to come back to it, you'll get the same data. So what if you wanted to, let's say, do a count of the number of people who are in this call, for example. So if you want to know how many people are in this call, it's an incrementing data, and incrementing data, it's hard to do it without doing mutation. So a Gen server can allow you to do that in Elixir without using such things like the Gen server, which will keep state. Then it gets a bit hard for us to do that. Okay, let's move over to today's topic now. I hope if you are not convinced, then maybe you might think about using Elixir. So let's move up to what I was to talk about today. That's architecturing of your application. So I look at architecturing of your application as an art of building. If you think about how architects build a house, there's so much that gets into that. They need so many people and so many parts to be moving. There needs to be so much project coordination that happens in the real world. So in our case, if you do software, it's basically almost the same thing. So I broke this down into how we can architecture our code. How can we make sure that the architecture of our code is okay? Okay. The next thing is, how do we architecture our files and concepts? So files concepts contains the codes. The concept is it deals with maybe the business logic or something like that. The system is it's a broad term that I just came up with. What I mean is, how do you decide what goes where? Not in terms of files, but in terms of sorry, someone is connected. Can you hear it? Sorry, someone is interfering. They're not muted. Okay. So the next thing is architecturing migrations. Under architecturing migrations, what I had in mind is, how really do you migrate from your old application, your legacy application, over to a new application? How really do you do that? And architecturing deployments, how do you get your code on to the servers at the end of it all? So that's the breakdown of our architectures for Elixir that I thought about doing and talking about today. Okay, so I need to do that. All right, so how can we architecture our code? How really can we architecture our code? So sorry about that. So how really can you ensure that your code is consistent? So the first way that you can make sure that your code is consistent The first way that you can make sure that your code is consistent, Elixir introduced a formatter that enables you to have consistent code everywhere. So that I'm sure in your team, in one way or another, or at one point, you always talk about where you should have the semicolon or how you should have it. How really do you need to, when should you put a comma or something like that? So the formatter does that for you. There's an amazing tool called Credo. So what Credo does is it looks at your code and tells you what are the probable mistakes that you have done. Mistakes in terms of how your code looks. And okay, let's put an example. Documentation. You need to document every of your Elixir function. So sometimes if you don't document that, the Credo will let you know that you've not documented it properly. And it has a very nice way of explaining to you why it thinks that is something that you need to be doing. So I'll show you an example of how Credo is and what kind of errors it normally gives at the end of this. Let's move over to Dialyzer. So Dialyzer is a tool that it works together with type specs. So what you do is in your code, you tell it what it takes in and what it gets out. So you can tell the code that it takes in a string and gets out, maybe say a list. So you have to tell it what it can take in and what it can get out. It doesn't have to be fixed. You can give it a particular set of options. The good thing about Dialyzer and from how I've used it is it kind of can predict what bugs you might get in the future, kind of, and not really. But the disadvantage of Dialyzer is that it brings out some errors that are hard to read. It's really hard to read Dialyzer errors before you get used to them. Type specs is, as I said, works hand in hand with Dialyzer. So if you declare a function, you tell it what kind of data it takes in and what kind of data it takes out. Documentation is so amazing in Elixir. It has one of the best docs I've seen in here. But you as a developer, you also need to do documentation. The other good thing about documentation is in Elixir is you can have it so that documentation is also your tests, so that your tests don't run out, how do you call it? They don't run stale or they don't become irrelevant. And what makes this possible is the immutability nature of the data that you normally have in Elixir. Documentation that can be run as tests is normally called doc test, so you can have a look at that later on. I'll provide a link to all these resources that I'm talking about. You can have your test coverage. Mix, which is a tool used by Elixir, also comes with the ability to check on your test coverage whenever you're writing tests. There's a whole not debate on whether test coverage is important or not, but yeah, it really depends on the team and if they look at it as important. Mix aliases, if you're using Mix to manage your Elixir application, Mix is a tool that enables you to do that. You can have an alias that can run a formatter for you, Credo for you, Dialyzer for you, and which checks your type specs and can also generate your docs for you just by doing Mix. Then you give it a command. One last thing that is not really tied to Elixir but is very, very important is code reviews. Code reviews is it's as important as the team. So I can't remember who said this, but there was a quote somewhere that says your team is as good as the worst person in the team. Not really the worst, but is as good as the not best. I don't want to call them the best, the worst. So your team is as good as the junior person, the most junior person in your team. So the more code reviews you do, the better your team gets all the time. So it's very important in stopping the bad habits, and it's also good for mentoring people into maturity. So that's how you can do your code and make sure that your code is okay. Just some of the ways. The next architecture is architecturing concepts of files. Okay, MVC is not a new concept. We are not. It's a concept that normally exists. So what you can do is you can decide. Okay, first of all, I have to explain why I did concept versus files, because the concept really determines where the files should be, kind of. let's look at an example of MVC. MVC is mostly used for the web because it involves the last layer, which is the visual layer that the user normally sees. So there's a framework in Elixir called Phoenix that employs the MVC architecture. You normally have the model, the view, and the controller. The controller controls the traffic that comes into your application and decides where this particular traffic goes. The model actually deals with persistence of data, kind of technically, yeah. And the view deals with what you normally see. So if you want to see a good example of how to do MVC, there's the Phoenix framework, which normally does this pretty well. So how it does is it gives you the ability to model your concepts. This is more of an abstract thing to explain, but it gives you the ability to model your resources. If you think about REST architecture, or maybe if you're using something like GraphQL, but if you talk about the REST architecture, your resources being something that you can manipulate. So the model can allow you to model or to structure your resources. The view is a gateway onto what you call a template. Sorry, I'm being a bit abstract on this. The view is what is ultimately shown up to the user. The other thing that I'll be using a lot of Phoenix in this, for example. Another thing that you can use to architecture this is the layered approach, where we have the presentation layer, the business logic layer, the other access layer. So the presentation layer, as we talked about, the view, is what the user normally sees. The business logic layer is where you make the decision as to who can do what and who can see what, or what kind of calculations are needed in this particular application. So the business logic layer is what normally varies from one application to another. So it really depends on which application that is. Data access layer allows you to access data, whether you're doing that from a database or you're doing that from a third-party application, either through HTTP or through HTTP or any other protocol that you're using that. So that's what the data access layer allows you to do. The newest in this is the domain-driven design. So in domain-driven design, there's a new concept in Phoenix called the context. So what domain-driven design is, it allows you to think about your entire application as domains. So let's say you're in an organization that has human resource as a department. It has finance as a department. It also has security as a department, for example. So you can, if you're developing an application for this particular organization, you can have something called a context for human resource, so that everything that the human resource personnel does goes through the human resource context. Okay. That aside, let's talk about another project that we've normally done. So you can think about a project that allows someone to maybe make payments and they can get what they wanted. So if you make a payment because you wanted a bottle of water, for example, you can have a context which handles payments. Okay, so it handles any form of payments, whether it's incoming payment or validation of payment or whatever it is. And you can also have a context that makes sure that what you have is being delivered. So it deals with deliveries. So you can have a context for delivery. Coming up with context is not that natural. It's not easy at first, but with time you can get used to them. The beauty of having context is that it allows you to have little lines of code for every context, so that you can avoid files that are as long as 3,000 lines or something. So you can keep your files to an insane number of about 200 lines to 300 lines of code. Once you get past that, then you basically need to split it down into some other context. Okay, so that's the good thing about domain driven. It allows you to do the context as Phoenix normally calls it, and it's a first class support in Phoenix, and it's easy to do that. Something interesting that I learned or I figured out on Phoenix is it doesn't really care where your files are, or Elixir. It doesn't really care where your files are, as long as you name your modules correctly. So in the MVC, for example, it doesn't tell you that you must have your views under the views folder. You can decide to have your views under the lib folder. You can decide to have one of your views under the lib folder. It will still compile and run as expected. So it's a bit liberal, but you have to be careful just so that you don't mix things up all the time. The next concept is migration. So this is mostly a question that someone asks whether when they want to move from one existing system to the next. It's not as easy because some people have very big applications that are hard to break down. But the first thing that you need to do is to find out which part you can start breaking down. For example, if you have a very big application, you can decide to do invoicing. Let's say your application has the ability, has a feature for sending out invoices to customers every month. So you can decide that that can be handled by Elixir. If you want that to be handled by Elixir, then you start by making sure that every month you develop this application that sends out the invoices. So the larger part of this application remains as it is. Another example that you can do is maybe you have your application that collects data frequently, your whole application, but there's that section that collects data. You can decide to have just that section that collects data to be in Elixir. Another example I told a friend I remember a while back is since you send out SMSs frequently, or when a new user joins in, then you need to send them an email. You can just start that with Elixir so that your whole application remains as it is, but every email that is sent out is actually handled in Elixir, or every SMS that goes out, it's actually handled by Elixir. One last way of doing that is just let's move over to load balancing. So once you have that, once you have moved to Elixir, I'm assuming that your team is not as big, or they're still trying to learn on Elixir. So what you need to do is you don't just deploy everything at once. So you can try to use load balancing that I have here, just so that whatever the existing system can continue working while the new system is picking up. So you do your load balancing as you increase the percentages with time, just so that you can fully switch out to the new application with time. Switching to a new application takes time, so you really need to be patient. It can take as long as 3 years, depending on how big your application was when you're getting into that. There's a great tool called Terraform that allows you to redirect your HTTP requests from the new application onto the legacy application. So if you decide that your application is you want to use authentication using Elixir, for example, then you can receive all the requests that you want, but any other request that is not meant for authentication is passed over to the legacy application, even though your Elixir application is what handles all the incoming requests. So you can use Terraform for that. The challenges when you're trying to do all these, mostly when you're just trying to get into Elixir or functional programming in general, is the mental shift that you have to do from object-oriented design over to do object-oriented design. Just a minute. Sorry about that. So the mental shift that you normally have to do, the fact that you have to think about data rather than how you're doing that. So it's normally the biggest challenge that everyone faces, and it took me quite a long time to do that particular shift. So it's totally normal. Now, architecturing your system, as I said, it's a bit of a vague and a broad concept that I was talking about. So there's these 3 ways of doing software generally. Let's talk about, I can start with monoliths. A monolith is one big application that does everything in your application. It handles every single element of your application. So this means that if that particular application is down, none of everything else is working, because it handles payments. For example, it handles payments, it handles SMSs, it handles generation of PDF files, it handles invoicing, it handles every single thing. The other way is service-oriented architecture, which is normally known as the microservices, where you can have different applications doing different things. So you can have one application that does purely authentication, then it passes it over to the next. The other application can be doing PDF generation, generating of PDF files. The other application can be working with generation of invoices. That's a service-oriented architecture. So that's generally what software architecture can be. So how Elixir can do this is under Monolith, you can build one big application that handles everything for you. Okay, you just do a mix new, then you generate your application, then make sure, then from there you build everything on top of that. In service-oriented architecture, you can do communication via HTTP, JSON, or XML files from one application to the next. So Elixir can allow you to do this particular thing. Umbrella applications is the new thing between this. So an umbrella application is an application that you can't call it a service oriented architecture, and it's not really a monolith, because your application, you can ship the application separately onto production, but you have different applications within this one particular application. So what I mean is I can call them sub applications inside your application. So you can have a mix file. A mix file is a way of Elixir to list your dependencies and take care of them. So a mix file, you can have one particular mix file that has all the dependencies. Then you have two other applications. Let's take an example of the invoicing system and invoicing system and the payment system. No. Let's use invoicing system and messaging system or emailing system. So if we have these two, they can be under one application depending on the same dependencies, but they can be shipped differently. Okay, that's what umbrella applications allows you to do. So it's the intermediate between software of the SOA and the monolith. Okay, if you have more questions about that, you can ask later on. Let's move over to how you can architect your deployment. One amazing thing about Elixir or Erlang that got me really excited, but I've not been able to do it, it's hot code reloading. Hot code reloading is the ability for you to deploy your application while the other application is still running, and you don't have to stop the other application. Okay, so if you have an application version 1.0 and you're pushing up version 1.1, you can basically push up version 1.1 without stopping version 1.0. So there's absolutely no downtime. This has been made possible, it's been working, and the reason it was introduced is just for historical purposes. Erlang was used for telecom switches, and the last thing you want to do is to drop someone's call simply because there was a system upgrade. So what it did, what it used to do was, if someone is on call, imagine this, if someone is on call and the base station is being updated, the call needs to continue even though there's new software that is getting in. If you had to stop this and restart it, then all the calls through this will be lost. So that's why this hot code reloading was introduced. It's in practice, it's a bit of a nightmare to do. So there are those who are experienced in doing it and they're enjoying doing that, because there's so much that you have to keep track of just so that this can work well. Sometimes you can have a build machine that builds the ultimate thing that you want. So there's this concept of having releases. You can have your Elixir release. So an Elixir release is this set of files which has Elixir in it and Erlang runtime in it for you. So the beautiful thing about releases is your server, your ultimate server, does not have to have Elixir installed in it. It does not have to have Erlang installed in it, because it comes with everything that it's supposed to have. An example of that is, I think I can use, I might not be correct to use this, but a Windows executable that you just double click and you do next, and everything just works because it comes with everything that it needs. So an Elixir release is kind of the same thing. So if I create a release right now in my machine and I give it to you, as long as you're running the same operating system, it should be able to work. You don't need any other special thing to do that. So in our case, for example, we do our build server works on Alpine. So we do our builds on Alpine, then we ship it to the we ship it to the final production server. The final production server does not have to have Elixir in it. So as long as the release is working, then everything will work on the build server. You can also use mixed release. That can also happen in things like Heroku. So if you're using mixed release, then sometimes you have to, not sometimes actually, all the time you have to pull down the dependencies, compile them, then you use mix to start up your application. Blue-green deployment, it's not specific to Elixir, but it's when you have more than one server and you can switch between the servers. You make sure that one server is deployed, it works correctly, then you move over to the next server. So you can use your load balancer to switch over between these two. Monitoring is also possible in your application. You can use something called the observer, which comes with alarm. You can use this to watch your memory usage. You can use it to check on which particular processes are currently running and who depends on those particular processes. Error handling tools, what is meant by this is you can really never rely on your customers to give you all the errors and the error details. They always just tell you it's not working. So how really can you capture the errors and report them to you? So there are amazing existing tools. You can use AppSignal for this. You can use Sentry for this. So what they do is, in case of any crash, they normally just pick these up and send it over to your account just so that you can have a look at them. So that should be the end of it, and I would welcome any questions or clarification that anyone has. So just feel free to ask anything that you want clarification on. Any question from anyone?
Hi. Hi, Sigu.
Yes.
So, thank you so much. That was a good session. Can you hear me?
Yes, we can.
Okay, so you talked about migration when someone is migrating from probably one application from probably one stack to another. So, taking for
Yes.
example, my application is built in Ruby, and I kind of want to migrate it to Elixir. So, what drives my decision for which parts exactly to migrate first? That's my question.
Okay, great. So first of all, the hard part about doing migrations is the client or the business owners. Sometimes they don't understand the importance of why you're doing migration. So to them, they're not seeing new features being developed.
Can I interrupt your call for a second?
Hey, Sigu, are you there?
Hopefully he can.
So there's a lot of white noise. I'm not sure. Let me just use this. Just a minute.
Okay, so we could probably keep the questions coming, and when Sigu is back, we can just probably add them to him. Is there anyone else who has questions? Okay, so hopefully I'm not locking out anybody. All right, so I'll take that to be the end of our webinar today. Sigu, if you can hear me, thank you so much. This was a nice session. Yes, do you have something to say, Jackie?
Generator has a question.
Okay.
And Kiran was also trying to speak.
All right, so Sigu is not available right now, so you can kindly leave your questions on the chat, and then we can forward it to him. Sorry, he'll be in touch once he can get back to you guys. So we'll have our next webinar session on the 27th of this month, is it? Of March, oh sorry, the 27th of March, and will be led by Paulo Buda. We'll kind of give you the details later on. So yeah, I think that's it from us. Thank you guys so much for joining, and we'll see you guys next month. That's it, bye.